Molten sea arc atomic reconstruction technology, a third-party expert opinion.
Ballsy thinking, the gender-agnostic antidote to sloppy thinking.
Well, if you follow this Ballsy Thinking channel for updates on the molten sea arc atomic reconstruction technology, MSAART, then boy, is this a video for you. Today we have a video which is of a third-party expert who visited the sort of reference site that we have for the big generators, so the 24 and the 18s, as opposed to the Chondas, which is the small hemispheres, so that's 4, 3 and even 2 as a transition, which is well documented on the web now, particularly since Tesla Tech. But this one is a site that's a worldwide site for the deployment of the bigger generators at a power plant. And the person speaking is George Lush from Lush Heating Limited. So I'll let you do your own research on him. But George has a heck of a lot of knowledge of annealing. The company's been in existence since the 1950s, and his knowledge of heat treatment and annealing metals, which is obviously the 24 and the 18s have been annealed by George's company, is extraordinary. So he came to the reference site, the demo site, where we have a version of the Chonda, and he had a heat camera which allowed him to measure different parts of the engine and the heat emanating from it. This was part of a bigger test that was being done on a Zoom call by literally many scientists from around the world who were looking at the test at the time, and I sat him down after that experience and asked him his opinions, and this is it. Right, so Gary Ling here, and I'm in the presence of George Lush, whose company has been annealing the hemispheres on this project. And George has come down to visit us on site. And so George, can you tell us a little bit about your background and who you are? And I know you like tea. So
yes, tea is the primary fuel.
Yes.
So yes, George Lush, my company is Lush Heat Treatment. We're aerospace heat treaters. We've been in the business for, well, many decades. We started in 1952. And our main business is space and aviation, metallurgy. It's all the high-end stuff. We work for British Aerospace, Rolls-Royce, with NADCAP, you name it, we're approved for it and by it.
And was I right that you were the annealers?
Yes.
Can you tell us a little bit about that process for the hemispheres which are used on this big project?
On this first iteration, it was rather a time pressure, so because of material availability and speed, these were just done as a sort of temporary first evolution in just mild steel, not in the expectation that they would be a long-lived device, but purely to prove concept. So we ran an anneal on the material so that it was homogeneous and uniform and would lend itself to further working, and then the welding and every other operation that's gone on. So I've come down today to see it all running.
And the what size were the hemispheres?
Oh yes, now this was a 2-foot outer shell with an 18-inch inner shell on these. That we did a couple of sets of these for early days proving concept, because we're fully conversant with the Feynman principle of everything that's going on here. That if your theory disagrees with experiment, it's wrong. So it's really been proving that point, and by goodness, hasn't it proven it with the data that seems to be coming off everything here today, and being lucky enough to come and see it for myself.
So the 24s and the 18s,
yes,
they were in stainless steel?
No, these were all just mild steel.
Okay.
First iterations.
Yes.
We do have other material to hand, which will be then the next evolution in stainless, but we're expecting to go beyond that into better materials for longevity, and as we're seeing, and then everyone else will discuss in much better detail than I do, the deformation and the magnetic properties that are occurring and the asymmetry of all these things, it's all going to need a lot more depth of data recording. So that's the other evolution that we're being very nicely asked to consult on and help out with, which is, I find, absolutely fascinating. The degree to which everything about this is so madly counterintuitive, and again, being asked to come out and experiment with take part on the experiment on site today, and running the thermal camera and seeing it for myself, it just astonishing results, and the difference of 300 degrees on just a small copper pipe, and the bottom chamber isn't even a chamber, it's just an elbow on this tiny little facsimile of the proper system, and the elbow at the bottom is 330 degrees, and the outlet pipe beyond it 4-5 inches away, it's 30 degrees. Now, I can tell you from the conductivity, I'm no great physicist, but the conductivity of copper, it's impossible to be 4 inches away with a flow going through from something that's 330 degrees, 4 or 5 inches away, it's 30 degrees. You can't just drop 300 degrees, it's not possible. But right. I've just seen it happening.
Right, so that was
today.
That was on the 432, which is, as you say, we call the Chonda.
Yes,
and that's
just
the smaller.
Just down at the bottom of the device.
Yes.
And seeing the top of the small sphere at the top on this little test unit, and 330 odd degrees, 340 up there, but then within a few inches on the transfer pipe dropping down to 180 degrees thereabouts. It's astonishing, but again, the temperature transition through where the 0 point in the middle of the pipe is, and then the temperature picking up again right down at the bottom in the elbow. So a small version of what seems to have happened from the thermals that I've seen on the big generator unit. There's no other way to explain it. The facts are there, the evidence is there, and I was panning the thermal camera up and down, quite convinced that I'm making a mistake here. I'm not hitting the right thing, but so many times up and down and up and down, and it was recording and showing the same thing. So hopefully when the film is examined and downloaded, it will give better data. And again, I'm not the steadiest hand with a camera, but time and again, 300 plus degrees on the ball at the top, down in 170, 80, something like that in the middle of the pipe, and then the pipe at the bottom where it goes into the elbow, 300 odd degrees, and then on the outlet pipe to the exhaust, dropping down to about 170 odd degrees in 6 or 7 inches. There's just, everything about it is massively counterintuitive, and there's no explanation for it rationally to be displaying just the temperatures and changes that are going on. So the diagrams that are posited from the earlier experiments and theories are proving to be exactly what's going on, but there's a lot more to learn here in terms of the behaviour of everything. I just, I find it absolutely fascinating.
Yes, so we've still got obviously the big testing on the 24 and 18s.
Yes,
we're on our way with that,
yeah.
Or we will be soon.
Yeah.
But you've seen all the construction of the stuff that with the components that you've put in.
Yeah.
It's quite impressive, isn't it? Really.
It is. It's really. It's always nice to see things that I've seen only as subcomponentry in their final state, but also that with decades of materials experience that we're going to, because I find it very interesting, we're absolutely going to be supporting this with as much help and advice we can as this R&D's up through better materials, better suited to longevity and to gaining optimum performance out of these devices, because there's going to be little learning steps and changes, and with the nature of how things are behaving at these experiment points, we're going to need to harvest a lot more data from a lot more points, so we'll be helping with that as well.
What do you think from your background, what are the sort of key production issues? So maybe give me 3 of the more important most important production
again,
issues?
selecting the right materials. You can go to stainless, but to be working stainless, it gets very soft at temperature. So we're probably going to go into aerospace superalloys, which will lend themselves better to manufacturing, because as far as we can tell so far, as perfect and concentric a sphere as we can produce will give the optimum performance on the device. So it's managing the procurement process of materials, the interstage treatments, and then the final treatments, because we're, again, extrapolating here, but we're thinking that it's going to need to be made from just the right aerospace materials so that it really works beautifully. People can then fit it and forget it for a long, long time, helping with the design stages on things so that it's easily serviced and replaced should that turn out to be something that needs to be addressed. But as we look at everything, make sure everything's optimised.
And we seem to find recently we had a problem with one engine, and the guys here, just using their initiative, seem to swap out the head or whatever it was.
Just exactly that.
And it's
just
extraordinary
to take that ability and scale it up so that when these are industrialised, and we've gone to 24, 48 inch, bigger and bigger and bigger, till we get to the size that it's now too large and unwieldy, and you're better off using several components instead of one big one. But there's so many variables.
Several spheres, for example.
Yeah, well, this is it. Say you have a big industrial power plant, you fit 4 or 6 or 12. I mean, our resident genius will work out the maths on this and work out what scale of capacity on this is going to be required. But just from my own interest, I ran out of fingers and toes, so I put it on a little spreadsheet, just thinking about the applications for this. So,
and what was the? Can you give us just a short outline of that?
All right. So, bigger power stations. Put them on power stations. The power stations are now spitting out 20% oxygen as their exhaust. Everyone's going to like that. The carbon dioxide and monoxide and particulates from what we've seen so far on the sensors drops away to zero, or so near to zero that it's...
Just to be clear, that's the sensors on the MSAART technology as it's currently configured.
Yes.
That's particularly on the Chonda, which is a small one, but...
Yeah, and it's making the point that even now, at just the first evolutions of this, that it's working so well that the MSAARTs are just turning out 20% oxygen as an exhaust gas, and you see it when they switch it off and it falls away, and then you switch it on and it comes up. So this plasmoid technology is really very troubling to try and understand, and it's almost an article of faith that you have to believe in something, and then you see it actually running. We don't have to believe in it anymore. You're seeing the evidence off of calibrated meters, and it's turning out, this thing's pumping out clean air. You could go into a Swiss mountain meadow. It's not as clean as the exhaust on this.
Yes,
I mean, that is a principle of just ludicrousness, just to illustrate how absurd and yet true the exhaust readings on this are. Now, I'm as skeptical as it gets. If you don't show me evidence, I don't believe you. And seeing these results, and just sort of not believing them, and I was looking at them when I was seeing them, I was just, no, I must be being stupid. I must be misreading this. This thing's putting out 20% oxygen, whereas before on this reading, before it was turned on, it's nicely running engine. It's sort of 11-12% carbon dioxide, and an engine running quite well, but it's pumping out pollution. Well, that's what you're going to get. Yeah. Then you switch this thing in, 20% oxygen, negligible carbon dioxide and monoxide, and it's astonishing, but it's working. The evidence is there. So yeah, returning to the applications, fit it on every power station. Another big pollution emission is shipping transport. So figure all the container ships in the world should have these fitted to them. Cruise liners, same thing. It's just that the cargo is passengers. All the trains running diesel, for instance, fit these on that. Your fuel economy is going to go through the roof. Your emissions are going to fall away to nothing. What else can we do? Oh, now the other one that I thought was interesting, and again, it's just a thought, but where the early evolution, where they played about with the Venturi just to see where in the pipe gives the sweet spot, they got cryogenic results. It was minus 50 or 60 or somewhere there. So right away the air conditioning industry just stopped, because you've got a 50-story glass office building in a city, and you put this technology down in the basement and you're pumping cryogenic air straight out of it. So you've got no refrigerants, no CFCs, no pollutants. You're just creating cold air as a byproduct normally, or cooler, but you can set this up to be pumping out cryogenic air, pump it around your 50-story building. So if you figure how much does it cost to run a 50-story New York City office building's air conditioning for a year, how much electricity does that consume with the attendant carbon and all the rest of it? Well, actually the power station outside New York's running this technology, so it's pumping out clean air. The air conditioning in this building is running on this technology. The savings are going to be just massive.
Yes, you're the first person I've been involved in this project for over 10 years that I've heard come up with that application of use.
So my brain runs sideways, and a lot of times it's really unhelpful, but when you're trying to think up things new, because I look at everything sideways, it's just my nature. I have many limitations. This isn't bragging. There's a load of things I am the worst person in the world at. Don't call me. I'll be no help to you at all.
Sure.
But it's just, it occurred to me that, well, if you're getting cold out of it, here's another one. You fit this to every vehicle. It's on every truck, every bus. You don't need a 22 kilo air conditioning pump under the bonnet of your car.
Sure.
Your car's running a tiny little plasmoid motor, as well as on the side, so you're using half as much fuel or whatever. You're getting all the power out of it. Your tailpipe emissions are 20% oxygen. You've got 1 million of these cars going around a city that's all smoggy and horrible, and then once it's these cars, each car's just pumping out 20% oxygen. The cars on the street become a big city park of trees that go down the road.
Yeah, I think that believe you me, I think there are a lot of the mega corporations who have that one in their sites. But George, look,
that's one. But you figure your car is now 25 kilos lighter. Set up one of the Venturis. Maybe we can set this up with 2 Venturis, one for main feed and one for cryogenic.
Sure.
That's your air conditioning. That's taken care of. That's
amazing.
A load of mass. You don't have to make air conditioning pumps anymore. The factory for that can be converted to something useful. You're not having to produce refrigerant gases. You're not having to recycle refrigerant gases. All of these things go away.
No, absolutely. Well, look, George, I'm so pleased that you're on our team.
I do a lot of really high-end stuff, and this is the most interesting thing that I've been involved in for years. It's I do a lot of R&D for quite out there stuff. This trumps all of it.
Fantastic.
I can't wait to see what happens next, but half the time when I get a call or an email about this, I'm thinking, oh God, I don't dare read it because it's going to melt my brain with yet another impossible result that's coming out.
Okay, well, we'll let you get back to your tea, but thanks so much for being here and giving us these thoughts. It's brilliant.
Been a fascinating day. Thanks for letting me come down.
Pleasure.
So if you're interested in finding out more about all the theories and so on behind it, as I've mentioned earlier, it's strikefoundation.earth, where Malcolm has posted all his research online. If you're interested in helping me to take the technology into Africa and to the poorer countries of the world, I'm Gary Ling, and I'm on gary@tradeassure.com. And if you're interested in investing in the technology overall globally, then the people to speak to, or the person to speak to really, is Christopher Foster at Alpha Prospects. All the details are below, and I hope that there's something of use for you here to be able to contact any one of us.
Ballsy thinking. the gender agnostic antidote to sloppy thinking.